Good morning, students. Once again, I welcome you to my video lectures on control systems. Now, after going through guides 1 and 2, now next to guide 3. A point on the real axis lies on the locus if the number of poles plus zeros on the real axis to the right of these points is odd. Now, whether the points on the real, one thing, as you know that S plane will have two axes, the real axis, horizontal real axis, and the vertical j omega axis. Now sometimes root locus can occupy the real axis portion. So how to find the real axis portion that is going to contain root locus? That is guide number 3. So for this guide, I am not giving you the proof, because if you follow I can give, but if you follow the guide, you will lose interest. That is going to kill your interest. That is why I am avoiding giving proof for this. Just I have made a statement and I will explain with the help of examples. Take for example, GSHS equal to K over S into S plus 1 into S plus 2. Now, first, count the number of poles and zeros. So in this example, there are 3 poles, S equal to 0, S equal to minus 1, S equal to minus 2. So 3 poles. That means there are going to be 3 branches of root locus. There are no zeros. Therefore, the root locus branches will terminate at infinity. Now, I will explain this guide. S equal to 0 is a pole. S equal to 0. S equal to minus 1 is another pole. And S equal to minus 2 is another pole. Now, I will explain this guide. If you take trial points here to the right of S equal to 0, that is these points. For these points, are there any poles and zeros on this side? No. That is 0. So, number of poles and zeros plus zeros to the right of these points, that is I am taking these points, to the right of these points is 0. Therefore, the condition is not satisfied. Odd condition is not satisfied. Therefore, for this example, there will be no root locus here. There will be no root locus here. Next, I will take the portion of real axis between S equal to 0 and S equal to minus 1. Between S equal to 0 and S equal to minus 1, if you take points, trial points, for these points to their right, there exists only one pole, that is S equal to 0. So, S equal to 0 is the only pole for these points. Therefore, one number, that is odd. Therefore, this portion of the real axis is going to have root locus, because this condition is satisfied. For these points to their right, the number of poles plus zeros is odd. Therefore, there exists root locus. There exists root locus here. Next, I will take points. These points between minus 1 and minus 2. Between minus 1 and minus 2, if you take trial points, for these points to their right, there are going to be 2 poles. S equal to 0 is one pole, S equal to minus 1 is another pole. So, number of poles is even. Therefore, there will not be any root locus between S equal to minus 1 and S equal to minus 2. Next, if you extend further, if you take trial points to the left of minus 2, for these trial points to their right, the number of poles is 3. 1, 2, 3. S equal to 0 is one pole. S equal to minus 1 is another pole. S equal to minus 2 is another pole. There are going to be 3 poles. So 3 poles means odd condition. So odd condition is satisfied. Therefore, there exists root locus. There exists root locus to the left of minus 2, S equal to minus 2. So in this way, you can take a good number of examples. Now for example, I will take second example, k by s square. K by s square. So k by s square, so as there are two poles at s equal to 0. 0. Now, if you take trial points here, for these points to their right, number of poles plus number of zeros is nil. And there will no root locus. There will be no root locus. Similarly, for these points to the left of s equal to 0, the points to their right, the number of poles is odd, not odd, even, because at s equal to 0 appears twice. Therefore, even condition. So, even condition is satisfied, not odd condition. Therefore, there won't be root locus at all. There won't be root locus at all on the entire real axis. There won't be root locus. Next, I will take one more example. K by s cube. K by s cube. If I take this example, there exist three poles at s equal to 0. As usual, for these points, trial points to the right, the number of poles plus zeros is nil. Therefore, there won't be root locus. But for these points, so that is the points to the left of s equal to 0, if you take them as trial points, for these points to their right, the number of poles plus number of zeros. So no zeros at all, only poles. Therefore, number of poles is r, 3. Therefore, the root locus exists on the negative real axis. On the negative real axis, there will be root locus, because for these points to their right, the number of poles plus number of zeros is r. Now, last example. I will take the last example. K into s plus 1, k into s plus 1 by s plus 5. Now here number of poles is 1, number of zeros 1. Now first locate poles and zeros. Zeros, s equal to minus 1. At s equal to minus 1, there is a 0. S equal to minus 5, there is a pole. Now, let us examine this guide. If you take points to the right of minus 1, if you take trial points here, for these trial points, the number of poles plus zeros is nil. Therefore, there won't be root locus. Next, points to the left of s equal to minus 5, that is these points. If you take trial points here, for these points to their right, the number of poles plus zeros is 2. S equal to minus 5 is pole. S equal to minus 1 is a 0. Therefore, 1 pole, 1 0 means 2 plus 0 plus poles 2. Therefore, it is even condition. Therefore, there won't be root locus to the left of s equal to minus 5. But between s equal to minus 1 and minus 5, if you take trial points, for these points to their right, the number of poles plus zeros is r, because one and only 0 exists. Therefore, r condition is satisfied. Even if you take trial point at s equal to minus 5, for that point to its right, the number of zeros is 1. Therefore, there will be root locus. Between s equal to minus 1 and minus 5. Therefore, this guide is a very, very important guide as far as the location of root locus on the real axis is concerned. Therefore, a point on the real axis lies on the locus. If the number of poles plus zeros on the real axis to the right of these points is odd. I hope students have thoroughly understood this guide, and I will going to extensively make use of this guide while solving problems. So in the next class, I will take up guide number 4. Thank you.